So here's an example of using the fundamental theorem of calculus to find the area trapped between two curves. In this example, I wanted to start off with kind of a hard one. Sometimes we need to solve for the intersection to determine the limits of integration. So in order to see what we're talking about here, what we want to do is we actually want to kind of graph these two things. And so we should think, all right, which one of these things is going to be on top and which one's going to be on bottom, so I can kind of use good colors here. Well, so I'm going to take a educated guess here and say that 2 minus x squared is a parabola that's been flipped over and then shifted 2 up. And then y equals negative x is kind of the downhill diagonal line. So I think that one's going to be on the bottom. So let's just draw a quick sketch here. Okay, so we're going to shift our parabola up 2. And so let's see, I'm deliberately not going to label my x-axis here. And so my parabola shifted up is going to look like this. And coming down like that. And then y equals negative x. Well, again, I haven't labeled my x-axis, but I'm going to go as perfectly diagonal downhill as I can. And then the question becomes here, if we want to know this area trapped in between these guys, we're after this area, we need to know this intersection input, and then this intersection. And that will give us our limits of integration because we have very clearly a top function and a bottom function. And since they don't cross each other, the green one's always on top of the red, we can do this with a single integral. So let's call this green one f of x because it's on the top, rename it f of x. Let's call this red one g of x. And label our picture accordingly, g of x and f of x are our top and our bottom. Even though I wrote the g of x on top, keep in mind that that's the bottom function with respect to the interval over which we are going to integrate. So the first thing we are going to do is we are going to find the limits of integration. And so how do we do that? We find the intersection of these two functions. And how do you find the intersection of a function? Well, you just set them equal to each other and solve them. So for f of x, our top function is going to be 2 minus x squared is equal to our bottom function, g of x, negative x. So I'm going to shift everything to the left because I see that this thing has an x squared term in it and an x and a constant. So I'm going to try and factor this thing to solve it. So I'll set it equal to 0 and we'll have x squared minus x minus 2, which factors nicely as the quantity x, let's see what multiplies to 2 and adds to 1, 1 and 2, and to get a negative x in the middle, we have a negative 2 and a positive 1. Two things multiplied together equal to 0. You know that one of them has to be 0, so set them both independently equal to 0 and solve them to get x equals negative 1 and x equals 2, respectively. And so these, our lower limit of integration is going to be x equals negative 1. And over here, our upper limit of integration is going to be x equals 2 for our integral. Let's see. Now, I could squeeze this onto another slide, but I have another blank slide made, so I'm going to go ahead and give myself a little bit of room here. I'm going to say, okay, so our area integral is actually going to be the area between these guys, trapped between these two curves, is equal to the integral from our lower limit of integration, negative 1, to our upper limit of integration, 2. And it's going to be f of x, our top guy, minus g of x, our bottom guy. So we're going to take 2 minus x squared, and from that we're going to subtract negative x. I like to use parentheses to kind of put the functions in place and then worry about the algebra to tidy up what we have in our integral. So what do we got? We've got integral from negative 1 to 2, negative 1 to 2 of 2 minus x squared plus x dx. Integrating that using the power rule, what has the derivative of 2? Well, 2x does. What has the derivative of negative x squared? Well, negative 1/3 x to the third. Plus, what has the derivative of x? 1/2 x squared has the derivative of x. We're going to evaluate this using the fundamental theorem of calculus from negative 1 to 2. And so, once again, we will evaluate this expression at our top guy, x equals 2, and then our bottom guy, x equals -1. That's going to give us 2 times 2 minus 1/3 times 2 to the third power plus 1/2 times 2 second power minus 2 times -1 minus 1/3 times -1 to the third power plus 1/2 times -1 squared, which gives us, let's just go ahead and leave this as an exercise, but if you work it out, you'll find out that you get 9/2 for your answer, and that in fact is the area in black that is trapped between these two curves. We just found that this area is equal to 9/2, which, if I'm not mistaken, is equal to 4.5. And if we go ahead and label our x-axis by 1s here, that seems pretty reasonable to imagine that we would have about 4.5 if you kind of draw the grids in there. You kind of count up the squares and figure out that, yeah, that seems like a totally reasonable answer. So let's pause here.